Okay, so we just left off with this particular slide where we talked about the phrases that translate from English to algebra for adding, subtracting, multiplying, and dividing the four primary operations. I also want to show you that I came across a really good graphic on the internet that I think summarizes all of this. And here it is. So what I would suggest that you do is you could take a screenshot of this. It'll help you with the words, put it into your notes. And as I mentioned before, I will be posting all of the PowerPoint slides on the website, but I'm not going to do that until I'm done with the entire chapter, which will be after the third day that we meet as a class. I don't want to put the slides up until after we've completed the unit. Okay. So again, this is a really nice resource, and it's got some things that you would use less frequently listed in here. Like for instance, with multiplication, they list triple. In 33 years of teaching, no teacher I know ever put triple up there, but it's really good to have. So this is a more exhaustive list. All right, so I want to do at this point, I want to work on just some examples of things. And this I borrowed this slide from Mrs. Teresi, and she wrote these things out. Just some examples of addition phrases. The sum means to add. So sum means you're going to add what? A number and 4. So x plus 4, n plus 4, anything like that. To more than a number. We're going to talk a little bit about more than and less than in a little bit. But to do 2 more than a number would be either x plus 2, n plus 2, or 2 plus x, 2 plus n. Again, we're going to talk a little more about that in a little while. 5 added to a number. If you listen to that carefully, 5 added to a number. That means you've got to start with the number and then add 5 to it. And that's why in the algebraic phrase it says x plus 5 and not 5 plus x. There's a specific sense of order when you say 5 added to a number. You have to start with that number. If I said the amount of money in Bill's wallet is $5 more than my wallet, then before you can figure out Bill's wallet, you've got to start with my personal wallet. So when you add to a number, you start with that number. A number increased by 7, again, a sense of order here. The number is being increased. So x plus 7 or n plus 7. A number plus 3, likewise, x plus 3. Now here are some examples for subtraction. The difference between a number and 2. Difference means to subtract, so it's x minus 2. You're starting with the number. The difference between 2 and the number, this is very important. This time you're starting with the 2, so you get 2 minus x. 2 fewer than a number. You start with the number. It's 2 fewer than that number. And the next one is 5 less than that number. In both cases, you're starting with the number, then you're reducing them. If you notice, Mrs. Teresi, Professor Teresi, she starred those. And we're going to talk and isolate that whole idea of more than, less than in a moment or two. Next, a number decreased by 7. You're starting with the number, then you're decreasing by 7, so x minus 7. 8 minus a number, you're starting with 8, then you're subtracting the number, so 8 minus x. And a number minus 3. Start with the number x, again a number minus 3, so x minus 3. So those are some good examples of subtraction. You know, one of the great things about watching the video is if I went a little fast for you, you can always rewatch. Okay. All right. So here's the note about more than and less than. Whenever you read the phrase more than and less than, you have to switch order. Notice 5 more than a number. We put the number first, the n plus the 5. So 5 more than a number is n plus 5. 5 less than a number is n minus 5. And being that Centenary University is located in the great state of New Jersey, and the prodigal son of New Jersey is one Bruce Springsteen, we can say there's a phrase that I taught my classes. I've been a Bruce freak since high school. This is a phrase that I taught my classes. Springsteen sang it on The Ghost of Tom Joad. It's actually a quote from the Bible. And it says, waiting on the day when the first shall be last and the last shall be first. So whenever I see more than or less than, fewer than, phrases like that with the then in there, I always say the first shall be last, and the last shall be first. So it says if we look at 5 more than a number, the first is 5, that shall be last. The answer is n plus 5. And the last, the number, shall be first. The n goes first. So the first shall be last and the last shall be first. 5 more than a number is n plus 5. 5 less than a number, again, first shall be last. So the 5 has to go last. The last number has to go first, n minus 5. So whenever I see more than, less than, fewer than, anything with the than in there, that always becomes first shall be last shall be first. Waiting on the Ghost of Tom Joad. Great song. All right. A couple of more examples for multiplication. Algebraic phrases, 6 times a number, 6x. So remember, no symbol between the 6 and the x means multiply. You could put a dot in there if you wanted to. You can see that Professor Tracy did that on the second slide. Nobody really does it, but you could. It's clearly understood. What you never, ever want to use is an x to represent multiplication, because then you would have like 6xx, and you wouldn't understand. Is that x the variable? Is that x the multiply? So we don't do that. We just said the product of 4 and the number is 4x or 4n. Twice a number means 2 times, so that's 2x or 2n. And 25% of a number, remember, of means multiply. So 25% is 0.25. It's also a quarter for those of you fluent in fractions. So 0.25x. And division English phrase examples. A number divided by 8, x over 8. The quotient of 5 in the number. Quotient, it's like the only time I ever hear the word is in here. 5 divided by x. The quotient of a number and 5. Notice the difference in order here. The previous one was quotient of 5 and the number. So the quotient, the 5 has to go first. It's in the numerator or the top. 5 over x. Quotient of a number and 5. Now the number is in the numerator. So that would be x or n over 5. And reciprocal means flip. Okay? Flip the fraction. So the reciprocal of a number, if the number is x or n, it would be 1 over x or 1 over n. Okay, let's do some practice here. How many terms are there in an algebraic expression? A term is a piece of the expression. Okay, what's the numerical coefficient? That means the number in front of the algebraic expression. What's the constant term? A constant term is a regular number. And what does the algebraic expression, or does the algebraic expression contain like terms? Like terms are terms that are the same kind of term, like 5n and 8n. All of these terms are terms that you should be comfortable with from high school, so we're only reviewing them very quickly. Okay? So, the answer to part A. How many terms are there in the algebraic expression? There are 2 terms. First term is 3x, second term is 5. Next, what's the numerical coefficient? It's 3. It's the number in front of the variable. C, what is the constant term? The constant term is 5. Remember, the constant means it doesn't change. It doesn't have a variable. And does the algebraic expression contain like terms? If so, what are they? They do not contain like terms. If it said 3x plus 5x, then they would have like terms, things that are alike. Okay, answer those questions for the next one, number 2. So, the first part, how many terms are there? There's 3 terms, x, 6, and 7x. What's the numerical coefficient? There are actually 2 coefficients in this problem. Remember, coefficients are numbers in front of variables. In this case, there's a 1, because there's a 1 in front of the first x, and there's a 7. What's the constant term? Constant term is 6. It doesn't change. There's no variable. And does it contain like terms? Yes, it definitely does. The x and the 7x are like terms. So again, these are words, vocabulary that I will throw out there that you've been doing since high school. So you should be comfortable with it. But if not, you can always refer to this to clarify what things like terms and coefficients and constants mean. Okay, so what we're looking for you to do right now is to this will be the last slide in this series. Evaluate each if A equals 7, B equals 4, and C equals 5. Do number 6. We'll go over that answer do number 7, we will go over that answer. Remember, pause. Okay, so the first one, 3b squared minus 2c. First, I substitute in my values. You can do this on the calculator, or you can do it step by step yourself. When I substitute the values in, the first thing that I have to do is the b squared. Okay, so the b squared is right here. It's 4 squared. I want to do that first, and I come up with 16. And then it's going to be 3 times 16 minus 2 times 5. So I do both multiplications. 3 times 16, going left to right, is 48. 2 times 5 is 10. And 48 minus 10 is 38. So there's the correct answer. The big to get here, the big understanding we're looking for is that you know to do that exponent first. 3 times 4 squared. Don't multiply by 3 first. PEMDAS. Parentheses, exponents. Do the exponent first. Okay, now try number 7. Okay, number 7 looks like such a simple question, but what we realize with number 7 is this. We have subtraction and addition, and when we say the mnemonic PEMDAS, a lot of people think that addition always goes before subtraction. That is not true. Addition and subtraction are equal in priority. The other day we told you a little story about how to get mom and dad upset. Mom and dad are equal. Whoever you see first, what they say to do is what you do. Likewise, addition and subtraction are equal. Whichever one you see first, going left to right, you do. So the first thing you have to do is 5 minus 4, which is 1. And then add 7. 1 plus 7 is 8. All right, that's it for the next video in class. We have one more video to go for today.